Hey, you guys got to help me. Is that picture clear enough for you to read? Is it focused enough?
Yeah.
Yeah.
All right. Not that I've read it yet. I haven't. But diving in. The figures below are velocity functions that are graphed for motion along a straight line, and assume the motion begins with the initial position at t equals 0 to be 0. So, and let's determine the following. The displacement between t equals 0 and t equals 5. In my picture, between t equals 0, number 41, and t equals 5. What do you guys think?
2.
Why?
Because it changes 2 on the y-axis. And displacement is how much it moved total, not like the entire length it traveled.
You know, I agree with that. Anybody else? You guys do it differently? Yes.
Because of the area under the curve.
And so that's the distance traveled. And so in the end, it'll be +3. Where'd you get that though? I mean, how did you get that so fast?
I did the homework there.
And you don't have to give me details, but just in words. I mean, did you build an integral? Did you look at areas?
Just broken down into triangles.
Could you guys catch that? So maybe he's not building up big definite integrals, but he is saying this with my green pen. I think the signed area of the first triangle computed as just merely 1/2 base times height is going to be 1/2 times 2 times 2. But that's just simply 2 units. By the way, did he give me units? Okay, he did. So 2 units, whatever the linear units are. Now, with the next triangle, though, I'm kind of nervous. I mean, where does it cross that horizontal axis?
It's technically
just call it-
1/3 afterwards.
Can we just call it 3.5?
No, it's 4/3,
How do you know that?
as the book says.
Oh, but without what the book's saying, how can you know I'm wrong by saying, oh, it looks like 3.5?
I used integrals.
Oh, did you really?
Yeah,
Well,
I tried to, but I don't think it worked.
You would have to do it both ways, but I think what you could do is you can look at the actual line,
Yeah.
build an equation,
Yeah.
Oh,
and then from there you can see where it crosses the x-axis.
you know what?
Yeah.
You guys are right. If I really were going to use definite integrals to answer the question, come up with the equation line. I'll do that if you like. I'm so lazy, I wouldn't have. Doing it his way, I'm this lazy. To get this local min, it's local max. Look at the y values. Here's -1 to +2. Notice how for a rise of 3 units, I run 1. So for a rise of 1 unit, I'm going to run 1/3. That's why I think this position right here is located at 1, 2, 3. Is that 3 1/3?
Yeah.
Sorry to use a green pen. Can I change colors? Let's you and I now talk about the area of this triangle. Here too, it's 1/2 base times height. So I think the area of that bottom triangle there is going to be 1/2 times my base, which is
4/3.
4/3 times my height, which is
1.
But that gives me an area of 2/3. So can I put a -2/3 in here? No, I can't. That died immediately. I said, can I put in a -2/3 right here? And lastly, this triangle, using my blue pen. I think the base has length 1 2/3. Is that 5/3? So the area of the triangles would be 1/2 times the length of that base times the height, which is clearly 2 units. But I think that just simply gives me a +5 half units. You guys, if I'm not being too sloppy, that is a 1/2.
Yeah.
My apologies, you guys. I said out loud this length is 5/3 of the base. I just wrote 5/2. My apologies. Shoot, I just lost track of what the question was. What was it? It was
Displacement.
find the displacement from TV equal to 0 to TV equal to 5. And I think to do that, I'm simply going to come in. Man, I really did blow up with pens. You guys, can you make the room? Can you look next to you or behind you? Does anybody see a nice black pen?
Pens.
Guys, I'm sorry. During the break, I promise I'll get a decent pen. But I think to figure out the displacement, I'm simply going to come in and come up with the sum of these individual areas, which are signed areas.
Professor Felga.
Yes, sir. Thank you so much. I appreciate that. Man, these are like power pens.
They have erasers on them.
They stick to the board.
No, the other way. Flat. Yeah. Oh, that one has staples on it, it looks like. Right?
It's so cool, right?
I think Target, Walmart, something
Really?
like that, yeah.
I've never come across them. So everybody, let's do the arithmetic. Does that give me 2 plus 3/3, which is positive 3? That's the distance I've traveled over the first 5 seconds. Do you agree?
That's displacement.
Yeah.
You should
Or
not
that's
agree.
displacement.
That's not the distance covered. I think that's just simply the displacement. So I think from t equals 0 to t equals 5, I'm at the end 3 units away from where I started from. How do I answer that question, which is come up with the distance traveled?
You just
You just
subtract the negative from the positive areas.
Nice. Or can I say it differently?
Yeah.
I'm simply taking these values
Adding them
and
together.
adding their absolute values. But that's just going to give me this. Or shall I say this? Or shall I say this? Again, whatever the units are. Did you guys agree? Did I go ahead? What was the next question? So I guess I've answered part B. Now what about part C? What is the position at t equals 5? All right, how about this? At t equals 5 is my initial position of 0 plus 13/3. No, I'm wrong. I think what I got to do is take that initial position at s of 0, which is 0, and add to it the displacement, not the distance traveled. And that'll give me the position after t equals 5 units. And so I think the answer is still positive 3.
So just to confirm, in the theorem that we mentioned,
Yes.
6.1, where it's like s of 0 plus the integral from 0 to t of
Yes, you're thinking of this. You're thinking of s of t at any time t. Your position is the initial position increased by the displacement from 0 to t of whatever your velocity function is.
and then that's just equal to 3 because or that integral is equal to 3, and then your initial position was 0, so that gives you.
I agree. I agree.
Isn't that dx dx, or is that something
My
different?
apologies. Thank you so much. I really did commit that blunder. That's not a trick. I really want this to be a different independent variable, so that once I integrate, I replace the x's with the t's with the fundamental pair. Thank you. You guys, I know I haven't answered part D yet. Do you think I can revisit A, B, and C and change something just to see if this is really clear? So tell me how to change with my red pen the first answer.
Plus 2.
Say it again.
Plus 2.
Say it one more time.
Minus.
Say it a third time.
Doesn't change it.
Doesn't change anything. I think it's still the same displacement. But now tell me how to change the answer to part B. I don't. I still think I travel the same distance. I think the only thing that's going to change is the answer to part C. Now I'm going to get my 2 plus 3, which is 5. Sir, did you see it? Because when you asked that question, it was a good one. But I think in this example, it's obscure because your initial position, you got lucky, it happened to be 0.
Right.
So the answer to part 3 isn't necessarily the same as the answer to part A, even though it wasn't this example.
Coincidence.
Yeah, pure coincidence. Or shall I say, because your initial position was at s equals 0. That's why. By the way, you guys, I like the next question. Part D. Although don't yell at me. I do confess that's a math D question.
D.
Can I erase this?
Yeah.
Well, everybody. Excuse me. Can I get rid of this?
Yeah.
Can you help me with these points?
2. Negative 1.
With 3 negative 1.
Yeah. 4, 2.
Can I call this the first line segment, the second line segment, the third line segment? Let's work on the first line segment. To come up with the equation for the first line segment, what do you want me to do?
Point slope.
Point slope formula works just fine. Although I admit, in this example, you could use the slope intercept form for an equation line. Actually, you know what? I'm beating that clock. Can I do just that?
Yeah.
Let's look at y equals mx plus b, because I know what the y-intercept is. I think that gives me y equals something times x plus 2, since 2 is the y-coordinate of the y-intercept. It's just the slope of the line is, with our mathy skills, the ratio of rise to run, which in this case would be -1. As far as line 2 is concerned, well, you know what? This is different. I don't have the y-intercept. I will do as suggested. I'll use a point slope formula to generate the equation of my line. Because it just screams out at me what to plug in. It's screaming at me. If I plug in x1, y1, and m into that equation, then I've got a linear equation in x and y. Let's do it. I think x1 and y1 are merely the coordinates of some known point on the line. Oh, look at that. There's a known point on the line L2. Or I could have chosen that one. It doesn't make any difference. I choose this one. I see that y minus my -1 equals something times x minus my +3. Let's find the something. It's merely the slope of the line. Well, we've already done that, haven't we? It was a rise of 3 over
1.
1. Let me clean it up a little bit. Does that give me y equals 3x minus 10? Next, you and I just talk about the third line. Well, I should say, excuse me, the third line segment. Here too, I don't know the y-intercept off the top of my head. I'll be lazy. I'll just slap down the point slope formula. And yet again, like I did previously, plug in what I know. I'm tired. I make silly arithmetic errors. Can I choose this as x1, y1 as opposed to that? It's just easier for me to deal with. So I see that y minus 0 is equal to something times x minus 5. Let's compute the something. It's merely the slope of the line. Rise over run is going to be 2 over 1, but it's going to be negative. I think I'm done. Now I can make my proclamation, my answer. I think my function has an output that's different depending on whether or not x is between 0 and 2, or if x ranges from 2 to 3. Or maybe if x is between... Did I miss something? What should that be? It should be 3 to...
3 to 4.
My apologies, you guys. I miscounted my ticks. You said 3 to 4. But what if x is from 4 up to +5? Well, I think the output of the function is going to change. How? Oh, I've already got the answers. Here's how the first time around. Here's how the second time around. And here's how the third time. Whoops, I never finished, did I? If you guys have checked my arithmetic, -2x plus 10. So everybody, to answer question part A or B, I know I answered the question looking at some basic geometry, but I think even Bradley, you mentioned, or someone mentioned, that you used integrals instead. No. To actually answer the first couple questions using integrals, you have to come up with this particular output first, so you know what to plug into the integrand's position.
Yeah, I did that.
Did he come up with something different?
Yeah, it looks a little different.
Can I see?
Yeah, I'm just kind of wondering like where he got all these values from.
Ah, those were the initial positions, is what he's referring to. What were they, 3/2?
3/2, 2.
Well, he's coming with the position function. Gotcha.
Yeah.
So what he's doing is evaluating the previous integral. He's
Okay.
evaluating that integral first to put in here, and then those integrals to put in there. That's what he's
Okay.
really doing. I just didn't go that far. I was just answering part D the way it was. I did
Okay.
the function. Come on, you guys, shake me up. Is that okay?
Top part was we changed it to reason. When the x was 0.
And thank you guys. I'm sorry for my blunder. Did you hear what she said? She's saying even the first part, I still made a mistake. I think for that first linear portion, it doesn't end at 2, it ends at +3. Thank you. David,
There's a little eraser on the end of your pen that you can use.
is there really?
On the other end. Right?
I'm so impressed. Any other questions on the homework set? Sir?
Is that V of t? Or does it ask for S of t? Is that
Yeah,
what you-
that's V of t.
My apologies, sir. I used F. I was simply saying, I can look at that function on the board, and I can come up with his output, but he doesn't call it F, does he? That's just a velocity function. And he's using a lot of T's. Can I not change that? T's, X's,
But
Y's.
I'm asking, do
He
we have
wants us to
to?
integrate and get this position function.
And you know what? I just didn't read the question well enough. You've got a good point. He's actually asking me in part B to come up with a position function, not merely just an algebraic representation for the velocity function. So point well taken. I'm just not finished yet. Since I'm not finished, how do we come up with a velocity over the time period from 0 to 3? Can I change the t's? Did I say that correctly? Was it from 0 to 3? By the way, you guys, notice how I use an inequality descent and close it here. Because these piecewise functions meet at the endpoints, it doesn't make any difference. You have equality here, just open it up there. If you have equality here, just open it up there. Where you have the inequalities, that's completely irrelevant. So somebody help me. Since this is merely my velocity function, tell me how to come up with a position function, at least over the first time interval from 0 to 3 for t values. I would. I simply come in a valued interval from
0 to 3.
0 to 3 of my velocity function, which is 3t minus 10, the second one.
Why?
Why?
You say I'm wrong.
Wouldn't it be negative x plus 2?
Where'd you get that?
'Cause it's
That's
from
the
0 to 3?
velocity.
Okay, you guys, I guess you're right. Since this is a velocity function, but it changes the output for various different values of t, I've got to be consistent. As x or t ranges 0 to 3, here's the corresponding output I used, not the second one. Do you see my point? Okay, I'll fix my mistake. Is that negative t plus 2? That is so cool. Of course, for the second one, if t ranges from, can you help me with this? I don't remember, is it 4?
3 or 4.
So I think as t ranges from 3 to 4, I've got a 3t minus 10. Are you happy?
Yep.
Are you happy?
No.
Yeah, I'm not happy either, because I think this is basically the displacement from 3 to 4 for t values, but I didn't put in what my placement was at t equals 3, so what do you want me to add to this? What do you want me to add to this? Whatever the position is, at t, thank you, at t equals 3. Did you guys see that? Now I think for values of t that range from 4 up to, help me, 5, where the output was, I can't read my own writing, negative 2t plus 10, then I'm going to integrate this as t ranges from 4 to 5. I'm going to integrate with respect to t, oh shoot, I'm not done. Because this is computed displacement as t ranges from 4 to 5, I need to add to this my position at was
4.
yeah, and t being equal to the initial value t here, which is the lower bound of integration. Do you see that?
Yeah.
And so I got to confess, I got to compute these. And everybody, watch. Did you compute this one number? Where do I go over there?
You don't. You have to find the position function in the top
Good.
one.
I go nowhere over there. That's velocity. I actually compute the evaluation interval. And that's going to be the evaluation of the first term. I agree. Are you happy? I'm sorry if I misread the question. Didn't go far enough. Anything else in the homework set? Sir?
I have a very quick question. You might have covered this already, but just to cover this. Number 19, it gives like a piecewise velocity function.
Number 19.
And I mean, the rest of it is pretty clear, but at the end it asks what is the position of the automobile when t is equal to 75. So the question I had was, given that this is a piecewise function, I mean, normally you'd find the integral of the velocity function and you can
Yes.
determine position from there, but given a piecewise function, how do you integrate over the piecewise function?
You do it exactly as I did here. You would take it in stages. You've got to be careful though. That notice how with this integral, I added the position at the end of this time interval, which is t equals 3. And also understand that to count this number is the evaluation of this interval. Right. So whatever number this values to, that's what goes in here, and then add another integral, is just in number 19, okay, I confess, you've got different functions instead of mine.
Right.
And I think over here, you know what, to be honest with you, I think this is such a nice, clean, pretty picture. I think probably be a lot easier just to do what I did in this last example and look at it geometrically. Only because these are such nice, clean, linear functions. One of it's just a constant function, a horizontal line. I think even looking at the pictures would be easier. That's just my opinion. But you could approach it exactly the same way I did here. If that's okay. Anybody else? Yes?
When you find the S of 3, should you plug it in the equation 3t minus 10? The position?
See, I disagree. I think my S of 3 is merely going to be the evaluation of this interval right here. Or shall I say, negative 1/2 t squared plus 2t as t ranging 0 to 3. Which, by the way, is the same thing as negative 9/2 plus 6, or shall I say, pop 3/2. Bradley, can I annoy you?
Yeah.
Because you have the solution manual.
Yeah.
Is that what you came up with S of 3?
Yes, I
Yes.
believe so, yeah.
So the author agrees.
Yeah.
And so, man, that's all I did. I talked my way through instead of doing the work, but there's the actual work I have. All right, if there's no other questions, the homework's done. Yes?
I didn't understand what 43 was asking.
So consider the following velocity functions on number 43, is that correct?
43.
Oh, I can't read. Hold it. In each case, complete the sentence. The same distance could have been traveled over the given period of time at a constant velocity. Gotcha. Guys, first things first. I'll answer this question fully. But graphically speaking, we need to figure out when this curve is above and below the horizontal t-axis. So you ready to analyze it to death?
No.
No, I'm not either. You know, I think at the left endpoint, when t is equal to 0, clearly the velocity is positive. And I think when t is equal to 4, the velocity is 0, which means I got a portion of my downward pointing parabola simply in the upper plane, the upper half plane. And so I think the area of the curve from t equals 0 to 4 is completely above the t-axis. So I think in the end, my graph looks something like this. T-axis, y-axis, this portion of the parabola, there is 4, and that's the graph of y equals my v of t. So I think to come up with distance traveled, I simply need to evaluate the integral from 0 to 4. I'm nervous. I should have absolute value bars in here. I should be splitting my integral if my velocity changes positive, negative, or vice versa, but it doesn't. I got lucky. I get the same thing as if I were computing position. And I'll put in my velocity functions, output. It's 1 minus, I forget.
T squared over 16.
Right, got it, thank you. And I'm integrating respect to t. Let's just deal with it. Does that give me this? Or does that give me this? Yikes, what is that? Is that a 4/3? I think. Or is that this? Ah, shoot. I just lost track of what I'm doing. What the heck does 8/3 represent? I asked the question. What the heck does 8/3 represent? You're right, the area beneath that curve. But it could also represent the distance traveled over the first 4 seconds. But if I'm traveling at a constant speed, wouldn't the picture look like this? T-axis, y-axis, horizontal line, and here's my positive 4, and I think the distance traveled could likewise, like over here, be interpreted as the area beneath the curve. Oh, by the way, what is the area underneath that curve? I said, oh, by the way, what is the area underneath that curve? 8/3. I want it to be the same distance. And I think there's an area of a rectangle whose area can be computed by looking at the length, which clearly is 4, times the height, which in my picture is. Oh shoot, I didn't tell you, did I? Oh, call it h for height. Ah, cheaper. That's just a math A question. Now to isolate h, I'll divide both sides by 4. So I think the constant velocity at which I need to be traveling is the height of that rectangle, which is 2/3 units, whatever those units are. Am I talking too fast? Yell at me if I am. I'm just talking fast because I think the picture is so straightforward. All right. Sounds like we're all happy, and I can move on.